Hello and welcome to this review session. So today we will be reviewing odd and even functions. So what is an odd function and what is an even function? So an even function is defined as if you change the variable to a negative say variable f of negative x, and if the result is equivalent to the original function f of x, then that's the definition of an even function. So examples of even functions are x squared, x to the fourth, x to the sixth. So those are even functions. So even if you replace x by negative x squared, it's still x squared. So that's an even function. So what about an odd function? An odd function in an odd function, if you replace x by negative x, then the function becomes negative f of x. So example of this is of course x cubed, x to the 5, and so on. So by the way, another example of even function is cosine. Cosine is an even function. So even if you replace say cosine of 30 degrees and cosine of negative 30 degrees are just the same. The sine, on the other hand, is an odd function. So if you have sine of 30 degrees and if you change it to negative, sine of negative 30 degrees is negative sine of 30 degrees. So those are even and odd functions. Okay, now one feature of even and odd functions is with regards to their symmetry if you plot the functions. So for example, even functions are symmetric, while odd functions on the other hand are anti-symmetric. By the way, I would just like to emphasize that not all functions can be categorized as even or odd. Not all functions, but some functions can be categorized into even and odd functions. For example, the exponential function e to the I, say e to the I theta. E to the I theta is neither even nor odd because e to the I theta, you can, by using Euler's formula, it's actually cosine theta plus I sine theta. So it's a combination of an even function and an odd function. So you cannot categorize e to the I theta as either even or odd. Okay, so to illustrate symmetric function, so for instance cosine, if you graph cosine of x, so this is x, this is cosine of x. If you plot it, so cosine of 0, that's actually 1. And then cosine of pi over 2, that's actually 0. So for pi over 2, that's actually 0. So the graph of cosine is something actually like this. But on the other side, the cosine of negative pi over 2 is also 0. So negative pi over 2, that's also 0. So if you will notice, on the positive side and on the negative side, the plot of the function cosine of x is symmetric. So for every pair of positive and negative values of x, they have the same value. That's what we mean by even function, and they are symmetric. Now let's go to the sine function. So for a sine function, for instance, it's an odd function, therefore it's anti-symmetric. So if this is the x-axis, this is sine of x. So sine of 0 is 0. And then sine of pi over 2, that's actually 1. That's the maximum value. But if you have sine of negative pi over 2, the value of that is actually negative 1. So that one. So you will notice that the graph of sine is actually like something like this. So it's symmetric. So the graph of sine is anti-symmetric. So here you have a a crest, but here you have a throw in a wave. So that's what we mean by symmetric and anti-symmetric functions. So basically, symmetric functions are even, anti-symmetric functions are odd. Now, one common application of even and odd functions, if you are, or if they are in the integrand, if you are integrating them. So if you have an even function f of x dx and your limit is even, say from negative a to positive a, so this is what we call an even limit. And if f of x is even, then the answer of this will just be, since if you will notice in the graph, the integral is just basically, if this is your plot, for example, it's a cosine, for instance. So basically f of x, if this is your f of x dx, say from negative a to a, is basically just the area under the curve, right? The area under the curve. So this is a positive area, this is a negative area. So if you will notice that, say this is from negative a to positive a, and if you will notice that since it's symmetric, you can actually just solve for the area under the curve on the right side of the interval on the positive x-axis, and then multiply your result by 2 because it's symmetric. So meaning, if f of x is even, then you can just integrate from 0 to a, the right side of the interval, 0 to f of x dx, and then multiply that by 2. That is if your f of x is even. Now, what will happen if, say, you have an odd integrand and even limits? So for instance, the sine function rather. So if you'll notice the sine function, it's anti-symmetric. So the f of x dx under this curve, you will notice that this is a positive area or positive value of the integral, this is the negative value of that integral, and that basically cancels each other out. And if you have an even limit, then all of this side will cancel with all of the other side. So you will get 0 if f of x is odd. So whenever you encounter integrals, first check if your integrand is either even or odd. So, if you are integrating on even limits, always check if your integrand is even or odd, because if you identify that, if they're even or they're odd, then your life could be easier by just using this property of odd and even function. So even limits, even integrand will just be times 2 of the integral of the half of the interval. But if you have even limits and odd integrand, then you don't need to integrate. The answer is 0 because of the anti-symmetry of the odd functions. Okay, so I guess that's all for this review, and I will see you again in our next review session.